If you see this question, when a particle moves in circle with uniform speed means omega constant, that is uniform circular motion. Uniform circular motion means the speed will remain constant, but at will become 0 because there is no increase in speed, which is responsible for increase or decrease in speed. Non-uniform circular motion, at will not be equal to 0.
Okay. Sir, you muted, sir.
For non-uniform circular motion, at not equal to, మనం నేర్చుకున్నాం లేదా? We have studied this or not?
Yes, sir.
At is equal to 0 for uniform circular motion. That means acceleration is equal to, so 1 will be an vector plus 1 will be at vector. This is 0.
Yes, sir.
But an vector also we got as r omega square into minus r cap. But this r cap also I told cos theta I cap into plus sin theta j cap.
Yes, sir.
I told you there, this magnitude may be 1 unit, but this always theta will change. This r cap will also change.
Yes, sir.
That means that
You gave those, no, sir.
and after some time acceleration will be like this. After some time acceleration will be like this. So the direction of that acceleration will also change. That normal acceleration, which is actually same. So velocity will anyway change because velocity also we have derived. V is equal to r omega into t cap we will get, which is the direction of tangential direction. Velocity always in the circular motion, tangential direction will change. Okay. So if you have learned that concepts in depth, we can answer the questions. Yes. We get this entire picture.
Yes, sir.
Next question. You see? So you see this question, two cars having masses m1 and m2 move in circles of radius r1 and r2. If they complete the circle in equal time, the point to be noted here. If you complete the circle in equal time, that means time period is equal to 2 pi by omega, we can take. Otherwise, omega.
Okay. I did it like this.
2 pi by time.
V is equal to R. No, sir.
That is this.
I did it in that.
I'll tell you what is the problem. Omega is equal to 2 pi by time period, right? 2 pi by time period. Because how much time taken to complete entire angle, a rotation? For one rotation, the time period is t. So one rotation, what is the angle covered? 2 pi. So omega is equal to d theta by dt. That is equal to delta theta by delta t. Delta theta is how much for one cycle? That is 2 pi by one cycle time period is t. Okay. Both of them complete the circle in equal time means this time period t1 is equal to t2. That implies omega 1 is equal to, right? So omega 1 by omega 2 is equal to
1.
There's no bigger picture to it because they both completed equal angles, equal times, then angular velocity is equal, right? Angular speed is equal.
Yes, sir. Sir, but I have done it in this way, sir. V is equal to R omega. Still, I should get no, sir. Why didn't I get?
What did you do?
I did V1 is equal to R1 omega by V2 V1 by V2 is equal to R1 omega 1 by R2 omega 2. I did, sir.
Okay,
I divided.
okay.
And then V is delta S by delta T, no, sir. Anyway, time is same. So for both delta S means like what they covered the whole circle, no, sir. That means circumference 2 pi R1
By 2 pi.
by 2 pi R2. I forgot to cancel this. I got. Thanks. Yes, sir, I got.
My solution, whatever I taught you, is as simple as possible. Okay.
Yes, sir, I'll do it. I'll follow it.
But there's another question similar to this on this concept. One question is asked 1 year. It's a bit confusing, but I'm unable to find it actually. Similar lines. Question is asked. M1 is to M2 something or R1 is to R2. I don't remember exactly the question. But you apply the concept and get the answer. If you don't get it, you approach me. In some of the previous year questions, question is framed on this.
Okay, sir.
Next question. Try next question. You see this question. Here there is a point called radius of curvature. Okay. Radius of curvature is, suppose if a particle is looking like it is traveling in a curve, at that time you just make a circle which is having this curve as a part of the circle. Okay. Suppose here it is a curve. You draw a circle which is having this curve as a part of it. Okay. Then we can assume the particle is assumed to travel in a circular path. It looks like as if it is traveling in a circular path for that particular part of the curve. Okay. So this here radius R1, this for the radius of this curve HR is called as radius of curvature. Now this is a bigger circle, right? From the diagram we can say RB is greater than RA. Now you draw the free body diagram. So if you consider, there will be mg downwards and upwards. So now if you see it is traveling in a circular motion like this, that circular motion means it should be provided by centripetal force, right? So mg minus n is equal to,
mv square by r.
this is the circle it is going. So centripetal force should be in this direction. So that means mg should be higher here. Mg minus n is equal to mv square by r1, mv1 square by r1. Okay. The question is given here, constant speed. Constant speed means that here whatever the magnitude we are taking, that is equal in both the cases, v1 and v2. So mg minus na is equal to mv1 square by r1. mg minus second curve is also similar to this. mg minus nb is equal to mv2 square by r2. Okay. So now, so Na is equal to mg minus v1 square and v2 square are equal. So mg minus mv1 square by r1. nb is equal to mg minus mv2 square by r2. v1 v2 here are equal. So if you see mg are equal, mg are equal. So if you see this r1 is less than r2, that means this value is greater than this value, right? Suppose this you consider x1, you consider x2. r1 is less than r2 means x1 greater than x2. Here when you are subtracting, x1 is greater means this Na should be lesser than x1 is bigger value, so you are subtracting a bigger value. This means this value will decrease. x2 is a smaller value, that means you are subtracting a smaller value. That means this value is bigger. Then that means Na is less than Nb. You got it?
Yes, sir.
Is this the way you did?
Yes, sir.
You know this way already?
You told, sir, this type of sum.
Oh, I don't remember. Okay.
This type means exactly not this type, but you mentioned this type of procedure.
Now in the same question, if you see, question is like this. Suppose a curve is like this. Okay. Here, circular motion is towards this. Centripetal force is towards like this. So n minus mg is equal to mv square by r. Got it? The equation will change a bit.
Understood.
Next question is on. Are you understanding how I'm approaching the problems?
Yes, sir.
You take a coaching material and try to solve these problems. Practice good set of problems on circular motion. We have banking of routes. That's it. That is left. Vertical circular motion and banking of routes. The two parts. Try this question. Check this answer.
Because there is supply.
You
So
see, if you question a particle of mass m is observed from the inertial frame of reference. I told you, inertial frame of reference means
sir, it is 0.
there should not be any pseudo force taken into consideration. And centrifugal force is a pseudo force. It can only be experienced by in non-inertial frame of reference. So the pseudo force experienced, the pseudo force is actually 0. Answer will be 0.
Understood, sir.
So if you are clear with your concepts, viewing the question paper becomes a bit more easier. Did we discuss anything new for just the solution case here?
No, sir.
But with practice, your subject understanding, your view, solving strategies, everything will develop. But whatever I taught you, questions to get more difficult than that, it's not easy to get from a certainly new concept. For BitSat preparation, if you are preparing for BitSat, questions will be like this only, simple questions. You need to be quick in solving them, accurate and fast. In BitSat concepts on conceptual basis, simple calculation basic questions will be asked. But the important thing is accuracy and speed. Accuracy will improve with understanding of concept and solving number of problems. Speed also. The more you are clear with the concept, your speed automatically gets increased. A particle of mass m rotates with a uniform angle at speed omega. It is viewed from a frame of rotating about the z-axis with a uniform. Okay, a particle of mass m rotates with a uniform angular speed. It is viewed from a frame. It is viewed from a frame rotating about the z-axis with the uniform angular speed omega naught. The centrifugal force on the particle is, what did I tell you? How to take the centrifugal force?
1 minute. Towards the center.
The centrifugal force is, as of now from the question, whatever I understood is, so like this, it's okay, this is, and they will, like this, it is rotating mass, and there is another object. This about this axis only. It is somewhere something else is rotating. From there you are observing with omega naught. Okay, what did I tell you? If you are observing, it is rotating with omega naught.
It is a non-inertial frame of reference.
How to take the pseudo force? Centrifugal force is nothing but pseudo force. How to take the pseudo force? You should keep the on this mass away from the, suppose you are rotating like this, omega naught will be like this, omega naught r square will be like this. Now the acceleration should be away. It is towards the center. It should be away from the center. So what is that? Omega naught into m, mass of the object, into omega naught square into r. Did you get this?
Yes.
Mass of the object into acceleration of the frame of reference. Mass of the object is m. Acceleration of the frame of reference is how much? R omega naught square. Frame of reference is rotating with the uniform angular speed omega naught, right?
Understood, sir.
Check the answer once.
Fifth one is B.
That's what, right? You understood? You have to take this concept. You go to centrifugal force concept that I taught you, and go to non-inertial frame of reference I taught you, where pseudo force concept. There I gave how to take the pseudo force, mass of the object that you are observing into acceleration of the frame of reference. Opposite direction is opposite to the frame of reference acceleration. The frame of reference acceleration towards center, and this will be away from the center. Here acceleration of the frame of reference is what? M into R into omega naught square. See, you see here. It is viewed from a frame rotating about the z-axis with the uniform angular speed omega naught. Frame is rotating with the uniform angular speed omega naught. You got it? This is a concept. You remember this concept? Acceleration of frame of reference, I told you.
Yes, sir.
If you are clear with this answer, there is no confusion whether we should write m omega square a or any other odds. Directly you will get that m omega naught square r instead of r he took a. Okay. Next. You see the next question. Did you get it or you have any doubt here?
I understood, sir.
See the next question. Simply states a particle is fixed on a turntable rotating uniformly. Rotating uniformly, that means omega is equal to constant. As seen from the ground, the particle goes on a circle. Its speed is 20 centimeter per second. Some circle radius r on the rotating table. Then its speed is given as, that speed is nothing but v is equal to r omega. Speed is nothing but magnitude of velocity vector, that is equal to v, simple v, which is actually magnitude, that is equal to r omega. If you want to write v vector, that is equal to r omega into t cap, the tangential vector cap I thought you. Now the speed is given, which is 20 centimeter per second. Then acceleration is given. So here it is uniformly going, so acceleration at will be 0. There will be only an, that is equal to what? R omega square. An. Magnitude wise. Agar acceleration wise you will ask, acceleration is equal to R omega square into minus R cap. Vector if you want. So this is how much R omega square is 20 centimeter per second square. The particle is now shifted to a new position to make the radius half of the original value. That means R is equal to R2 is equal to R1 R by 2.
It2.
Now the new values of speed. Speed is what? Here omega is constant because it is going in uniform rotating body. So V is equal to R2 omega V2. Then A2 is equal to R2 omega square. So omega square both are not changing from the previous values, but this R2 is only changing, which is equal to R by 2. So velocity will also become half and acceleration will also become half, which is 10 centimeter per second. 10 centimeters. Now,
Yes.
solving the question is that how clearly I am approaching a question. Having a good clarity of very minute things. Okay, then let us go ahead. The question is, from here onwards, you will learn about banking of roads. There is a car. Which is going in the circular path. Is you circular kind of curve. Okay, its car mass is m, and the coefficient of friction between the tires and the road is mu, and this radius of curvature is r. The question is, find the safe speed for the turn. And it is turning with uniform speed. Tell me that speed. Okay. This is flat road. Okay. Horizontal flat road. You try solving this question. Okay. Now the thing is,
You said that in circular motion we don't have mg, no sir.
no. So, there for the centripetal force, you don't need that relation. Doesn't mean that the forces are not acting. Mg will act, normal also will act. So in all the cases, horizontal circular motion, what we thought, these forces did not come into our picture for calculation because centripetal force is not provided by these forces. Okay. It's not that they don't exist. It's just that we don't need them in the horizontal circular motion problems particularly. So here you see the situation. It's a flat road. So if you draw the free body diagram like this from a cross section, there will be mg and there will be normal reaction. Okay. 1, 2 forces I do. And is equal to mg here because it's a flat road. The other point carefully see, here it has to take a turn, means it should move in a circle here. So for a circle, uniform speed here it is given here. So you don't need any other tangential force. Minimum that is required is, I already told you about this, centripetal force. And sometimes the centripetal force is provided by friction, sometimes normal force, sometimes gravitational force, sometimes electrostatic force. This we have learned already in the previous lectures. Now that centripetal force is provided by here, only friction here. Okay. So because friction. So but that friction also cannot be unlimited. It has a limit, Fs max, static friction. Otherwise the car will skid. The car should not skid, means go in this direction with a higher speed. So it should not skid. If it should not skid, that means whatever centripetal force is there, that should be less than or equal to the maximum frictional force. If the centripetal force is higher, required means it is going with a higher speed. If it is higher than the friction maximum that static friction can provide, then this friction cannot stop this car sliding in this right side direction. Okay, got it? Got it? So that means that centripetal force should be less than or equal to Fs max, because here friction is providing that centripetal force. That means m into V max square by R is less than or equal to Fs max is mu into mu s into m. That means V max square is less than or equal to mu s into n by m into R. So V max square, safe speed means equal to we can take. It should be less than that speed. Whatever we are going, it should be less than that speed. Finding out that limiting velocity. Limiting velocity is a safe maximum safe speed. So m will be here mg mu s into mg into r by m. Vs safe speed is equal to root over mu s rg. The speed, this is a maximum safe speed.
Did not cancel that n with replace it with mg, sir. Else I got the same.
Okay. Maximum safe speed. Got it? if you see the banking of roads concept, here, first I will solve with smooth road, okay? Then I'll introduce friction to the picture. Because on here, if you see the cross section, it will be like this. It is like turning like a circle, okay? It looks like turning like a circle. I do this circle here. The radius of curvature is r. So now, this is smooth. I have to get. So you need to, this is mass car of mass of car of mass m. Then you need to find out what is that safe speed. Yes, safe speed. We'll try solving this. We'll discuss. If you see this question, if I draw the free body diagram that I've already taught you on mg, there will be normal reaction. This is theta, this is theta, mg cos theta. So I can solve in a number of ways, resolving this mg cos theta and mg sin theta also. But you see, this is theta, this will be theta, and this will become n cos theta. This will become n sin theta. I'm resolving normal reaction here. You can resolve mg cos mg also. It's not a problem. You'll get the answer. So n cos theta is equal to mg here. N sin theta is actually providing that centripetal force, which is in a horizontal circle, right, towards the center, which is mv square by r. So if we take tan theta is equal to v square by rg, that means v is equal to root rg tan theta. Okay. If there is no friction, but if friction comes into picture, there will be a range of speeds. There will be a minimum speed because
It has static and kinetic friction.
no. If friction is not sufficient, so slowly the car will slide downward direction. Okay, in the downward slide, like a block sliding downwards. Got it? If we have a speed less than minimum speed, this car will slide in the downward direction, right? If we have a speed higher than a particular value, the block will slide in the upward direction. Got it?
Here I directly resolved mg force, sir. So I got mg sin theta is equal to mv square by r. But my doubt is, why did you resolve normal force, sir?
mg sin theta is equal to mv square by r. How will you get mg sin theta is in this direction? Circle is in this direction. Okay. Here
We need to take normal perpendicular force, no, sir?
we can take mg also. You'll see the problem here. You see. But along the circle, I need to find out here. Along the circle, we need to get that centripetal force, right? That's why I resolved their normal reaction to make my job easier. That's it. Here, for a rough surface, you understood this? For a rough surface, there will be a normal like this on the car. There will be mg like this. There will be theta like this. Then this is theta. This will become theta. Okay. So now for a minimum speed, I'm taking first case. Minimum speed means what happens? The car will slide in the downward direction. Okay. So to stop it the limiting value should be acting in the upward direction, right? So friction will be in the upward direction. I'm taking for minimum, I'm taking the friction maximum here, supporting my friction. So now here I can take mg one thing, mg cos theta. In this direction, this is mg sin theta. N is equal to, we know, that is mg cos theta, right? Here sliding down, it should not happen. That's why. There centripetal force is provided by. Directly I took that speed. There you will get only one value. You cannot have more than that. You cannot have less than that. If you have more than that, it will go upwards. If you have less than that, it is directly slide down. There's no other option in the first case. That's why directly I took the circle case. So centripetal force is provided by that n sin theta, and that mg will be balanced by n cos theta, so that it will not slide down or slide up. But in this case, it should not slide down. Friction is also there. Friction will adjust. That maximum friction value will adjust. Suppose 20 newtons it is required. Maximum is 30 newtons value, so it will adjust 20. 19 required 19, it will adjust. It cannot adjust to 35. That's why I'm taking the along the plane. I am trying to resolve the values. Mg sin theta, mg cos theta. There it is not needed for me. That's why I did not solve. Mg sin theta, f the upside. Why I took upside? For minimum value, friction will be up in the upward direction. Okay. Now, mv square by r, if I am standing here and trying to find out, there will be mv square by r in this direction. So if this is theta, this is 90 minus theta, this will become theta, right? So this will become this side. mv square by r I am resolving here along this plane. Plane. So mv square, this side will be mv square by r cos theta. Did you understand this? This is theta, this will become 90 minus theta, this will become theta. mv square by r cos theta. Then in this direction, mv square by r sin theta. Got it? Cos of 90 minus theta, the sin theta. So here if you find out n plus mv square by, carefully see here, if you are sitting on the plane, just sitting on that car and observing, the car should be at rest, right? For non-inertial frame of reference. Just to make my solution easier. So then this mv square by r will be towards the center, right? Away from the center. This is circle and you have to take away from the center. So this is theta, this is 90 minus theta. So in this side it will become mv square by r, mv square by r, cos of 90 minus theta, that is sin theta. And this along this line it will be resolved. Are you understanding? So this side will be that whatever I got this side will be that side, because you have to take the pseudo force in the direction. mv square by r cos theta. Got it? Now, so for V minimum, I already took the direction. V minimum, friction should be that friction's maximum, and that is upwards. Because for minimum speed, the car will slide downwards, friction will be upwards. For maximum speed, we will take Fs maximum, friction value. Limiting values we will take and find out, okay? The velocity can be in between. So the friction will be downwards. For maximum speed, the block will try to go in the upward direction, slide in the upward direction. So the friction will be downward direction. So first case I took here. So what are the diagram I got? One thing is normal here. Here I got it as mg cos theta. And other thing, what did I get here? mv square by r, mv square by r sin theta. In this direction, I got a friction value. In this direction, I got mg sine theta. For minimum value, friction will be upwards, right? Then that pseudo force resolution will be here in this direction, mb square by r cos theta. Now, just to balancing condition, I am taking that mb square by r cos theta plus friction should be equal to what? Mg sine theta. Got it? Are you understanding this? Mv square by r cos theta.
Yes, sir.
Fs is mg sine theta. So then Fs is how much?
Yes, sir.
Mv square by r
And
mu s into n. N is how much? N is here mg cos theta plus mv square by r sine theta, right? Okay. Perpendicular to the plane is equal to mg sine theta. So here you can take mv square by r on one side, mg on other side. So mv square by r, if you take cos theta plus mu s into sine theta, right? Mg, if you take common, sine theta minus mu s into cos theta, right? So mv square by r, mm cancel. That v minimum square is equal to rg into sine theta minus mu s cos theta by cos theta plus mu s sine theta. V minimum is equal to root over rg into sine theta minus mu s cos theta divided by cos theta plus mu s sine theta. This formula you need to remember, okay? Just I solved it for you. I'll give you a technique to remember. Because only after solving, I tried to find out. It's very difficult how to remember. Just in my preparation days. Then I tried to find out a technique to remember for myself. Then for a maximum case, what will happen? Friction will be downwards, right? Huh? Same diagram.
yes, sir.
So maximum case, what will happen? Again, normal will be like this. There will be mg cos theta plus mv square by r sine theta. But here is this side, what will be mv square by r cos theta. But this side there will be mg sine theta plus friction max. Okay, got it? Here V max you are taking, upward will be higher. So friction will be acting downwards. So then simple here, mg sine theta plus fs max is equal to mv square by r. Here maximum. Maximum I'll find out to 2. mv to square by r into cos theta. Cos theta. But here fs max is mu into n here. N is nothing but mg cos theta plus mv square by r sin theta. Got it? Are you understanding this? Ujjwala?
Yes, sir.
So then I'll try to bring mg on one side. Mg if we take in one side. So sin theta plus mu s cos theta, that is equal to mv2 square by r into cos theta minus mu sin theta. Got it? Are you understanding? How did I do it?
Yes, sir.
So cancel. Again v2 square if you find out rg into sin theta plus mu s cos theta plus cos theta minus mu s sin theta. Got it? So V2 is equal to root over RG into sine theta plus mu s cos theta by cos theta minus mu sine theta. Are you understanding? But the
Yes.
important points to remember here, see, is you see some pattern here. Sine theta minus mu cos theta by cos theta plus mu sine theta. Here,
Yes, sir.
huh?
Yes, sir.
Here minimum value we need. Numerator will be minus. That's what I figured out at that time to remember. So maximum value you need plus, just plus minus exchange, values will remain same thing. Because friction will be upward in the first case, downward in the second case. In exam, you will not derive everything, but I just want to give you the thought process. Sometimes a part of this derivation might be asked a question, just that's it. Just a very small part of this derivation. In understanding how to draw the free body diagram. That's why I taught everything. But the basic thing is, if you want to remember the formula for bigger things, RG into the fraction will be downwards there. If numerator minus, denominator plus, the minimum for minimum value. Here fraction will be upwards, opposite side. So it will be maximum value, numerator it will have plus and denominator it will have minus. Got it? Both the cases sin theta, mu s cos theta, mu sin theta. You see sin theta, mu s cos theta, mu s sin theta. Now another technique.
Yes, sir. I understand.
If no friction is there, what? That means mu can be taken as 0. That friction values can be taken as 0. So you take it to be 0.
Under root RG tan theta.
Under root RG tan theta.
This is what we did in the first question, no, sir?
First question without friction. Minimum value sin theta RG, root over RG into sin tan theta means sin theta by cos theta. So sin theta, in that case sin theta minus mu cos theta by cos theta plus mu sin theta for minimum value. For maximum, ulta. Sin theta plus mu cos theta, numerator should be the bigger. Cos theta minus mu sin theta. So it becomes easier. So but 1 year exam, one question has come. At that time, because just when I started my career again after 4 years of preparation of this JE and all, when I started my career, one directly in exam, the question has come, final exam. So in the final, student has asked me how to solve this question. At that time, I don't remember everything at all, just because I started my career. This time I'm being a trainee faculty. So I exactly don't remember. Then I solved this question in 5 seconds. How did I solve? He has given number of options like this: root over RG square, root over G by R into sin theta cos theta, sin theta cos theta, like that. They have given a diagram. Then I told him, question asked is speed, maximum or minimum, whatever it is, speed is asked. So your answer should be speed. So what did I do? Sin theta is a ratio, cos theta is a ratio. So ratios will not have any dimensions. So this is dimension plus dimensionless plus dimensionless. Mu is also a ratio, limiting friction by friction by normal reaction. So these are all ratios.
Yes,
ratio plus ratio is a ratio. Ratio plus ratio is a ratio. So this is actually a ratio. So this do not have any dimensions. This is my second calculation. Options in options. Then I told you. So now this, whatever the value RG square, R by G square, whatever the value, you need to find out, you need to get velocity finally. So root over R into G. R is L, G is L by T power 2. So L root over L square by T square. That means root if you keep L by T.
Okay.
That actually velocity. Then I told him this is the correct answer.
That is actually a nice method, sir. I used to do this in exams many times.
So I just told him directly in exam because it's an exam. But later on, I thought I need to once check this entire derivation. So I tried to analyze it deeper into this derivation. But sometimes when question looks so tough, there's only one option there, correct option. It is having only a root or RG. I don't remember exactly the day when he asked. The student got impressed. Sir, if you don't know, also you'll get the answer. So then sometimes you don't need to know everything in finally securing the marks. How much presence of mind you have. But conceptual knowledge, I always prefer to have the clarity, problem solving skills, number of practice, number of examinations and problem practice with you. Then with good presence of mind, you can crack the exam very easily. Just you need to have the presence of mind and calmness to see this thing without any panic. Okay, we'll discuss in the next class. Then only vertical circular motion is left. After that, we'll switch on to the next topic, center of mass, momentum, collisions, and rotational motion. So this mechanics will be completed. Mechanics main part will be completed.
Okay.
Then we'll go to we'll discuss in further class.